So welcome everyone. Good morning Sam. Thank you for doing this session with us for Zettalane Systems. It's probably new for most of the people in the group, but we will understand why in a few minutes. So my name is Philippe Nicolas. I'm the organizer of this. This is the 66th edition of the IT Press Tour, Day 3, Session 1.
So good morning everyone. So I am Supramani Sammandam, founder of Zettalane Systems. So we are building a cloud-native storage, redefined. So it's kind of an honor to have you all here. So international US and international tech journalists all in one group. It's really a privilege to have you all here today. So about me, so I've been in the tech industry for 25 years in various roles, working doing soft storage engineering.
Yeah, please continue.
Initially, back in the first wave of software-defined storage, I created something called the Maya store, but not the same as the current OpenZFS Maya store. At the time, those days, 2005 time frame, it was Falcon Store, Terracore, those guys would be familiar. That was the early software-defined storage. So I had this Maya store, IceCurry, Target Stack, Fiber Channel, and VTL at the time. And then this great recession made me stop the first venture. But I saw that opportunity right there when with the SAN and things like that. So I wanted to continue the journey that was stopped a long time back, because with the disaggregated storage, so with the NVMe over fabrics, you still get the same SAN concept, much more modern, and on top of that you have this cloud. So I want to improve that storage solution on cloud, make it more easy to use, consume, and at the same time cost economy.
When you say ZFS, it's OpenZFS?
Yeah, it's OpenZFS, yes. It's a ZFS. And I have done a port of specifically for Zettalane ZFS also, that was covered in the OpenZFS on Summit talk recently.
So there is no...
It was like officially it was like 2018 time frame during the COVID time. So that kind of made me slow in making progress. But now, and then I couldn't continue actively on that, because I was looking at some AI infrastructure solution and things like that. So, but now the time has come that I got to make something, have more momentum with the Zettalane Systems. And surprisingly, luckily, fortunately, I have you guys coming here and noticing it and taking a look at this.
What about, what did you do just before Zettalane? Is it Maya store?
No, before Zettalane, so yeah, my progress to storage, early software-defined storage, I was the founder there. And then after that, I tried my luck with some startup companies, which was the all-flash storage startup companies.
Like
Arcologic, right around the time Pure Storage, those were formed. Arcologic.
Yeah, Arcologic was one of the first full flash NAS.
Right.
Yeah.
Too early. And so over there, I was a director getting record SpecSFS numbers and things like that. So that was my achievement over there. That's where I got involved with ZFS. So that was the first wave of all-flash storage, and then the second wave was the scale-out storage systems, right? That I did not play with. It was too complex, scale, and it doesn't give. So the performance per node doesn't fan out well if you look at a scale-out storage solution.
What happened to Maya store?
Maya store around 2007, and this great recession happened. So I thought it didn't make sense for me to continue further with that, because it was too risky, I thought. I was too young at the time. Right, so I have a good background on storage. I understand the issues and the pain points, and that's why I thought, so let's improve something on the cloud. where storage, it's so expensive and it's not very easy to consume. So this, again, the company, what we are trying to do is like, we have tried to address both the pain points. One is to reduce storage costs and at the same time give the best performance you could with the disaggregated storage. So based on that, so we got to make it should be developer friendly, so easy to use. API driven, one-click deployment, right? So infrastructure as code such as Terraform. So those are all the main things we focus on. Like for example, if you have like a researcher or somebody who wants a storage to consume with this with this research workload, who has no knowledge on storage, it's just easy for them to run a script and the storage is available for them without, it's basically zero touch. They don't have to go and configure one or provision storage or things like that. So they just inject a JSON object or whatever, they define it and then the storage is available for them. And at the same time, we want to make sure it's cost effective because if you look at traditional solution out there, so what they have, all the big players, they just brought in their complete stack, whatever that used to run on-prem, they run the same thing on cloud. It's not that much cloud native. So they just consume a bunch of EBS drives and then try to put the storage solution. That's not cost economy, and that's not cost effective. So at the same time, the architecture has to be scalable so that it addresses the small workload to the big workload. If you see all the enterprise solutions right now, they try to manage services. They are trying to address very enterprise large workload. You got a minimum of 100 terabyte even to start with to make sense, right? Things like that. So at the same time, for any enterprise storage, we have to make sure it's highly reliable with active HA and the ZFS unlimited snapshots and data integrity. So these data management services. So all this, so we want to build a new modern storage solution using all these features.
Who is this going to be most interesting to? What type of companies? What level of the company? What person in the company are you selling to?
Right. So right now, the small business that we're starting with, and then the developer oriented, and then slowly we get into enterprise.
So small business, 10 people, 100 people, 1,000 people, as opposed to 50,000 people?
It depends on 10 like whoever wants to consume on the cloud. That's what we are focusing.
Everybody wants to consume on the cloud. However, they don't have a pain point until they get to a certain size.
Right, like the pain point being is for small players, they are left out. They need to start with 100 terabyte. What if somebody wants this 4 gigabytes high throughput? I only 1 terabyte of data set.
Right.
So that's where we come in. And then, so we try to get into large enterprise. That's going to take some time to get there, right? So, honestly, we got to start with small and then see how far it can go.
Maybe some enterprises buy some of your clients and you get in that way.
Yes. And also through partnership, we will address the enterprise market.
Yep.
Yeah. So what we have provided is a solution block. I'm sorry.
And when you said it's one-click deployment, where do you deploy the software? In your own computers? In the cloud?
Yeah, that's a good question. So So if you look at the existing solutions, they make sure it's accessible to the internet because they kind of control and the data and monitor and things like that. But in our solution, we don't. It's in their private VPC. They don't have no call home kind of feature. They don't have to call home, like we don't it doesn't dial into our company or anything. So we don't know what is happening there. So it's totally their own network and then their own Terraform based deployment, their own resources. So we won't even know what they're doing. So and everything is managed in the cloud marketplace. So again, the challenge, little slightly talking about that. So it's the traditional way to use storage, right? It's a block storage. That's the easiest way to consume storage solution on cloud. If you were looking for a managed file storage, then you have like managed file AWS or EFS. They're very expensive, and on top of that, they put a lot of restrictions. So like the Google Cloud file store. So the per client throughput is limited. So things like that. Right, if you start small capacity, the performance is not there, then you have to still work on IOPS. The pricing for IOPS would be different. So things like that. So these challenges are, should ring a bell. So this is pretty common.
Do you consider that a lot of users really use AWS EFS instead of other file storage services from the marketplace or from AWS itself as an alternative of this? Because there is plenty of different services.
Yeah. So right. So you're talking about the data sovereignty and things like that, or
No, you mentioned here AWS EFS.
yeah.
But many people who using cloud and AWS in particular use something else. They could use some offering from the marketplace,
Right.
or other services like FSX.
Right.
FSX.
Yeah, I'll talk about that
Okay,
soon.
okay.
We have our one of it.
Okay, very good, very good.
So that's a good point. So yeah, of course, we are just I'm just comparing with the default option available there. Okay, whatever the public cloud provider is providing. The tendency is to consume EBS if you're on AWS. Yeah, there are other solutions, and each one come with their own pain points. It could be the storage controller could be a bottleneck. And so right now there is no solution AWS doesn't do that. FSX doesn't work directly on the object storage. So they do have some kind of tiering, intelligent tiering that can help you move stuff from to object storage. But ours is different. There is no movement. It is directly on the object storage. We'll talk about that pretty soon from the architecture. So so we'll differentiate. We'll talk about the product differentiations pretty soon.
Very good.
So I'm sure that the other services that you mentioned, they are also trying to address the same pain points.
And the fact that there is plenty of solutions, or at least several solutions, justify or confirm that there is an opportunity.
Right. Yes.
Yeah.
So we have this try to add a little differentiation or the special sauce so that we have to do that to stay competitive. So what we are doing is we have two products essentially. One is for file storage, the other one is for a low latency block storage. Okay, so this file storage. So what we do is we have this hybrid ZFS. So the ZFS, we make use of a special architecture of ZFS called it's known as a special VDAV only. So by keeping metadata on the ZFS special dev, and then for the bulk storage, we use object storage.
So it's like a gateway, ZFS gateway to with a cache to an object storage.
Yeah, the cache. It's just not really a cache. The metadata is on an NVMe or SSD, so it's too super fast. And then object storage for throughput, you don't need to cache. They blast it out to the object storage. It can do, it has a 200 gigabits per second backend bandwidth. All the cloud providers have that. So if you have a workload that can sequentially stream, it's way faster than the local other storage that's natively available on cloud. Even faster than NVMe on throughput sometimes.
Because you have several disks actually in parallel. That's why there is.
Yes, exactly.
Okay.
Yeah. So so object storage, it's like bottomless. It's this massive scale out already. The way they built this whole object storage on cloud, ZFS is an advanced file system. So it's not like a simple fuse based file system. So it has like you mentioned, it's concurrencies there, extreme parallelism. So you could see like thousands of SSL connections going onto the object storage backend. That is why you get this extreme throughput, 4 gigabytes per second. If it attach one EBS, one volume, it can do only like 700 megabytes or something like that.
How many nodes can you manage? And 4 gigabytes is very fast. So what kind of is 10 gigabit Ethernet or for the network?
So you need a network optimized instances to achieve this type of bandwidth. For example, the way the cloud providers have it is they let go. They don't put a limit on network throughput for object storage. But whereas the EBS and all those things are capped.
And how many nodes can you manage? How many nodes?
Yeah, so
for the beginning it's one?
The deployment could be single, active HA, or active passive. And then, so you can have multiple deployments of those HA pairs. So you could have any number.
And so you said you don't have to pay for the network traffic. You don't have to pay for the fact that you use many disks actually.
Yeah.
No, there is no extra cost when you.
Yeah, so this is within the same network of the cloud providers, same region. So there's no egress.
Yes.
Only when you go to some third-party cloud site provider, you have to pay for the internet cost.
Yes, obviously, but when you use, for instance, S3 at AWS, actually you don't know how many drives there are behind your S3, just a bucket. But in your case, I suspect you ask to have several drives to have this throughput. So it's a demand, so it's an extra demand. So
Yeah.
maybe I suspect AWS or GCP or Azure will make you pay for this, no?
Yeah, it comes as part of the instance. The type of instance you deploy comes. It's the network bandwidth is attached to the per core of the instance. So in order to deliver this 4 gigabytes per second, you gotta have a little bit. High-end instance, like more cores, more. The way we have is in the Terraform. So there are many the policies are there. So you could do 2-node, which comes with like 10 gigabytes per second. Like that, it goes on. So if you have like say in Google. N2 iCPU or the standard 48 that can do 32 gigabits per second by default. Then what we do is we enable the tier 1 premium network, which is free. That's why you leave it. Basically, you leave a lot of stuff on the table if you're not exploiting that. That is why our solution makes it friendly. For example, like the stuff that I talked about, the researcher who wants to run his workload, he doesn't know how to configure a jumbo frame or how to optimize the network and things like that. Right? He's focused on his work. So that is why this Terraform module configures everything properly depending on the cloud you are deploying it. So for AWS, we know what the jumbo frame size should be, how to enable the accelerated networking on Azure, how to enable the tier 1 premium network on Google. So those are the, we handle that. So it will be obvious when I go deep into that. Yeah, you're right. So you need a matching network bandwidth. So each cloud provider provides a different way of addresses this problem. If you take Google, they are very generous with the network bandwidth. You saw is AWS too. They have many network optimized instances. Azure doesn't. The network is not that great, but they are addressing that. They do have network optimized instances coming up pretty soon.
Back to the question Serge asked a few minutes ago about the number of nodes. You said we can use pair.
Yes.
But if I want, let's say, an horizontal cluster of 10 or 12 nodes for load reason, can I have these nodes participate together and offer a large NVMe block storage pool?
Yes, you could do a little bit. So we take like one step at a time. This is like as a solution blocks, and you get like a pair, like you mentioned, and then you can build more powerful solution. Let's say you put a PNFS on top of that, or then you get a full scale, like the cluster network you're talking about. Yes.
So for you, it's just you deploy a pair because you want HA.
Yeah.
So you deploy a pair. Can I add a third node, a fourth node to this cluster?
Yeah, but that's an independent cluster.
So it's multiple pair.
Multiple pair, and so that you don't get into the same issue of bottleneck by the storage controller. You know, the traditional scale out, they do have this many number of nodes in the back end trying to communicate each other, and then they have bottleneck in the back end. So by having multiple HA pair, so you combine with the modern like PNFS, flex files, those type of stuff, global namespace. We try to address using that because we're not trying to do everything all within here. We try to provide a solution block so that people can build on top of that.
So the limitation for the HA pair comes from the ZFS, some ZFS limitation probably, no?
Now, kinda, yes, and then also it's more elegant to have NetApp still has a 2-node HA, and then from that you could grow on. It's much simpler to manage. Then again, you run into the same issues of scale-out network being complex to manage and things like that.
I agree, but with NVMe now and NVMe over Fabric, any node can potentially be connected to any NVMe device.
Yeah.
And you can, let's say, partition, build, stripe with a very wide factor across all the NVMe device.
Absolutely. So that becomes like a data platform kind of setup. Yes, we can support that.
Okay.
Yeah. So so the other thing, so this is different. So this Maya scale, this is a NVMe over Fabric. So you're making use of the local SSD, the ephemeral instances. So we do active HA.
If someone is interested to also deploy this on-prem, is it possible, or you support only cloud?
Right now we support cloud. It is possible. It's just like, we need more resources to support on-prem. Okay. Yes, it's possible. Absolutely possible. So right now, if you take Maya scale, it uses the NVMe TCP on cloud. If you're on-prem, you could use the RDMA.
Yeah.
And we are validating on cloud too. These days it's possible. We have done that successfully, and you get 40 microsecond latency with InfiniBand at the Rocky over Ethernet. It is we tested that, so it is possible. So once we have that, we would be that would be the only solution that can provide RDMA NVMe on cloud, public cloud.
But at this time, your business, a major part of your business come from the cloud or from the on-premise?
This has no on-premise.
No,
it's only cloud.
No,
it's possible on-premise, but it's only cloud.
Yeah. you're focusing on cloud because as a small company, it's much easier because you got the help. You're getting help from the public cloud providers.
You said it before. You can deploy on premise. If no, you don't say that you can deploy your solution on premise.
On premise.
Yeah, on-prem. We could. We have that too.
But he was saying that they need more investment to be able to do it. They're focusing on cloud
Right,
for
right,
now.
right.
They're not doing
So-
it on-prem yet.
Yeah, on-prem, so we don't have control over what resources out there. Whereas on public cloud like GCP, we know exactly which instance, what bandwidth, what.
That's why, because at this time you have a lot of discussion in Europe with the cloud and the sovereignty, and some people prefer to deploy on-premise.
Yes,
That's why
right. So
we have a
on-prem.
lot of discussion in Europe at this time
Yeah.
with the American hyperscaler.
Right.
And some people are going to switch to on-premise solution.
Mhm. Yes.
Well, there's also discussion in Europe about getting rid of the American tech stack altogether because of the political fights. So, yeah.
Among the three, AWS, GCP, Azure, what is the top platform for you?
We focus more on GCP.
Why?
Because so AWS is already established, so they don't look at small players, so GCP, for example, FSX is not on GCP.
Yes, so it's because there is offering on AWS is already pretty rich.
Yes.
But you say, okay, GCP lack of some solutions.
Some solutions,
Okay.
right. There's some storage gaps.
Okay, so
And we try to address.
it's a tactic.
Yes.
It's more tactic.
And it has nothing to do with the fact that because GCP, they tell us we have the best network, it's very fast.
Yes.
So that it's not related to this better network.
Yeah, you nailed it. Yeah, that is what it is. So GCP was they're a latecomer, right? They tried to, in order to compete with the AWS, they were giving so many resources for free. Their NVMe was plenty, that the ephemeral instances come. So the no restrictions, like good bandwidth, network bandwidth, and then same with the network premium tier 1, it's free. You don't have to pay extra. For example, if you a standard instance when you deploy, it's only 32 gigabits per second only. Any instance that has more than 32 cores, you can have a premium tier 1 network. It takes you to 50 gigabits per second or 75 gigabits per second easily.
Do you think Google's going to raise their prices or become less generous as they get more successful?
Yes. Yeah, they do, because initially they gave those low NVMe instances. After they switched to titanium SSDs, those are very expensive. So that is why in MayaScale we do not use the newer instances. That they're not, because then it becomes expensive, just like AWS. So the older N2 family instances, the NVMe, local NVMe, it's cheaper, much cheaper. And everybody is playing the same thing. Even now Microsoft, they have a storage optimized instances where they throw NVMe just like that. Earlier it was not that good. Very poor but still they have a very poor network bandwidth. They don't. It's very difficult to get an instance with more than 16 gigabits per second on Azure unless you throw in several hundred cores. The instance has to have more than say 60 core, something like that. That's so in a GCP, a 4-core CPU can do 8 gigabits or 16 gigabits per second network easily. So this is how. So this is the hybrid this ZFS architecture I was talking about. So you have this. This is pretty native to ZFS. So they have something called a special VDAV here, and then so this hybrid. So hybrid means the sense there is no movement of data from you say all our existing solutions. They try to stage into a NVMe, and then based on life cycle they move it to object storage. So that's like they're wasting the power of object storage, the bandwidth. So what ZFS here, MyNS is doing is, based on the record size, it knows. See, by default, all metadata stays on the NVMe. For example, if you have like 100 TB storage provisioned, so you could have a very small, like a 10 GB for the NVMe, not entire 100 GB on the block storage. So you just have a little bit on the NVMe, and most bulk storage goes to the unlimited object storage. That's the thing. So this is pretty common. If somebody is doing like a 4K media streaming, they tend to be large files, large record size. It can read or write. They are a sequential I/O pattern in nature, so you can read from object storage at extreme speed.
4K media streaming?
No, for 4K video, yes.
Okay, 4K video, because...
Video, yeah. Large, they tend to be large files. And
yeah, large files, so large block size,
Yeah.
1 megabyte block,
Yes.
etc. Yeah,
Yes.
okay.
And the NFS also
Yeah.
uses 1 MB block size.
Okay. 4K resolution for the video. Okay.
Yeah. I'm not talking about the 4 KB blocks, I/O size.
Yeah, because it's completely...
Yes, yeah. So just I'm just throwing a little example here. Yeah, if you have all this Slurm job and things like that, they tend to read a little configuration. Hundreds of worker clients, they read small files for the config related, right? And then, so that would be like a IO storm. So that the special NVMe, it doesn't go to object storage. So once the job definition and all those things are read, then when they are actually executing the job, so the files associated would be like a training data set, right? Large files. So that can naturally come from object storage. So yeah, so there is no data movement. So once it's returned to this NVMe, it stays there. It's always hard. So for example, if you are doing memory caching, so there you need, then the concept of the metadata can be called on an instance restart. So it has to the metadata has to warm up. Whereas here, like it always stays in the NVMe. And same thing for your large block data, it just fetches directly from object storage. No caching. So you could see, so imagine like pumping 4 gigabytes per second throughput. So you cannot do caching there. You just run out of memory there. And then it doesn't make sense. So it does a direct I/O to object storage, and the object storage can handle that. Even though it's a 200 millisecond latency device, but for throughput it is fine. So the existing solution, what they do is they try to cache it in the memory, and then they slowly write it out. That doesn't fully utilize the maximum connections and things like that. So this is our value add to ZFS. So what we have done is we wrote a Golang program based program called Object Backer. So this is not a fuse based or anything. It just attaches in kernel direct there's a ZFS VDEV layer. Just act like a block storage, and then it hands it off to this object backer.io program. So, well, you know all this pain points like fuse layer. So it tries to split the I/O. So for example, when a 1 MB I/O size is coming in from NFS mount point, that 1 MB goes to ZFS, and ZFS will just hand it over that 1 MB I/O size direct to the object backer program, and then 1 MB will be written directly onto the object storage. If it is not 1 MB size or a smaller size, then it goes to the local metadata for a local special NVMe. It's automatic based ZFS. So again, so the other value add is we just use the vendor provided Go SDKs to deal with the object storage API. It's an API from them. So everything is well tested and proven. And the same thing is the ZFS is also trusted and it's well known in the community, and we just make use of that. So the risk is minimal here. Yeah, this is the benchmark results we have.
And it's really important to have active ESHA when you are in the cloud.
Well, kind of yes and no. Yeah, sometimes cloud can act strange too. So
Yes.
yeah.
But yeah, because it will be in the same region. It will be. I mean, if there is a problem, actually,
Yes.
it will be the even if you have a active solution, both will be unavailable if there is a problem. No, so.
Yeah, well, yeah, that's why you put it in a different region. See, the good thing
Okay.
about object storage is, compared to object block storage, EBS,
Mm.
is you don't have a cross zone or a regional block device storage. Object storage, by default, it's always regional.
Yeah.
Yeah. So that's advantage you have. And then,
Okay.
and it's already, you could deploy 2 nodes in a different region,
Okay.
and then it will work.
Okay.
Yeah.
I see.
And
But in that case, it will be replication.
Because you have the latency for the synchronization, no?
no, we don't use replicate. The object storage by nature is available everywhere. All is a Z-pool export,
Okay.
and then you just import on the other node. It's a shared
So
storage
you rely on the data propagation.
of the backend,
Okay.
yeah, cloud provider. Yes, they do that. Everything, you can even have more settings on the backend cloud provider. They have object storage when you provision. You can say, I want the near fastest with the latency and things like that. So it keeps it in the same zone as where your instance is. Or you could relax it, saying that I want more cross zone, multi-region. So that while creating the object storage bucket, we can specify. So yeah, this is the type of instances. So you get like with the 48 CPU, the 75 gigabits you get with the tier 1. Otherwise, it's only the 32 or 50 only, I think. So here, there's like no caching. It's just directly writing onto the block storage. So this is a little performance graph. So the test we are conducting is share 1 on one node, it's writing, and then it's reading like that, it goes on. And then the concurrent, so this is from all this coming from a single NFS client. So that's the advantage here too. The existing solutions on cloud, you need to have, per client is only limited to 1 gigabytes per second. So all this can be validated. The way we have done is pretty transparent. So we're going to provide these scripts to run this. We just call it like say validate Maya scale and validate Maya Nasdaq script. Anybody could run it, and then they can verify. So this is a little bit on the multi-cloud aspect of this. So yeah, so we touch the on-prem. So what they need, what they have to do is they have to install a Maya NAS on a VM instant machine.
And so, just to be sure to understand, what is this Maya NAS on-prem? It's just a gateway to access, to connect you to the cloud, actually. There is no local storage, this kind of thing.
Exactly, yeah. You don't need any local storage.
You don't need, but for instance, if I want to have some local storage to accelerate.
Yes, you could do that. Yeah.
Okay, so it's possible.
Possible, yes, yeah, of course. Yeah.
Okay.
Yeah. So yeah, I mean these would be like existing storage players. Yeah, you could like TrueNAS or whatever, other enterprise solutions. So that you could define a Maya NAS as a Z pool. Then if the other player is also ZFS, you could do ZFS send. It's pretty intelligent way of replicating, similar to NetApp SnapMirror.
Okay.
So like, yeah, so this is send and receive. So you just have a data set kept here, and then it can replicate to the same Mayan as on the cloud.
Okay.
So it could be used for backup and DR purpose.
And what do you recommend actually, to use a backup on premise or to use a backup in the cloud? Because actually in the cloud it's very fast thanks to your solution. So when you say you could use it for backup on premise.
Yeah, so it's very fast on the cloud because as long as you stay within the cloud. If you get out to the internet, you try to use third-party object storage service like Wasabi or other storage, then it gets expensive.
Yeah.
You have to pay egress cost and
Yeah.
but in here, yeah, you could. But same thing, you could have like object storage on a third-party object storage here.
Okay.
Like, yeah, you could do that. And the Wasabi, let's say, is here. From Google Cloud, you don't have to use their GCS object storage. You could use Wasabi.
Okay.
So the throughput would be the internet speed, right? Whereas if you are within their own network, then the throughput is faster. So with, let's say 100 gigabits or 75 gigabits second, that's applicable even to the GCS backend. You get the same amount of throughput. Once you get onto the internet, it's not it's a different level of pricing and performance SLA for network internet bandwidth. Yeah, they do. It is not bad. It is pretty good too. You can go up to 32 gigabits per second and things like that. So multi-cloud on various public clouds, right? The challenge is here, right? We provide a consistent experience to the user. So no matter what cloud they're using, they don't have to worry about so many things. How my network virtual IP address is going to be, what type of object storage, is it S3 compatible or not? How do I get the access key secret and things like that? And then for the metadata, special VDEV for ZFS, what type of SSD to provision, and then what type of instance. So all these are handled transparently in the Terraform module. So they just type validate myanas.sh, which I show in the demo, then pretty much it figures out what to do. Because the virtual IP address is different, the floating IP address for the failover. You need to use the IP alias in GCP, or you have to do a custom route table in Azure, like ENI attached, so like that. So we handle it pretty much, everything. And the type of deployment, if it's AWS, CloudFormation, if it's Azure, ARM template, and then Google Cloud supports Terraform now, their own Terraform provider. But then, so there is a lot of red tapes to publish a marketplace solution. You cannot do too many things there. Sometimes you cannot run a Spot instance from the marketplace, because Spot instance, it saves you a lot of cost, right? For somebody who wants to have a workload and then just run it for a small amount of time and then tear it down. Spot instances are great. They're not running it forever. But by using this Terraform external, they can do whatever they want. What are the API they provide. So that's why we do provide a common Terraform module for all the clouds. So if these are all for the marketplace. If you are in AWS, the marketplace can only do CloudFormation. If it's Azure, it can only do ARM template. That's a single click on the marketplace solution. But from their local workplace, they can do Terraform from in their GitHub action or anywhere. CI. So as a DevOps, they can do Terraform, which is a common thing. The only GCP already has a Terraform for their marketplace, so we try to use that over. So yeah, everything is taken same heartbeat cluster, HA and things like that. So when they deploy using the Terraform module, by default, it creates a Z pool and exports one NFS share. Actually, two NFS shares, and then tells you the Terraform output will tell you like how to access those shares. Very straightforward. Like you don't have to log into the storage console and configure the first share and things like that. So next we move to this MySQL, which is basically NVMe or fabrics on cloud. So using, because those are ephemeral instances, local SSD, so the data goes away when you shut down the instance. So we have to have active HA. No other way there to protect the local SSD. So here, so what it is for? So what we have done, so yeah, so you can easily have over 2 million IOPS, low latency, extremely faster than the block storage that's currently available, right? Let's say like hyperdisk or PD Extreme. So within this MySQL, we support two modes. One is the normal like a plain block storage mode. So it uses the standard Linux RAID 1 MD as the data plane. So no risk there. So we are not trying to do a complex erasure coding or making it a bottleneck. It's simple, so with as minimal overhead on the server controller, on the storage controller. We just have the basic RAID 1, so which is needed for databases. Like if somebody wants to run a self-managed Postgres SQL, then yeah, this is a perfect solution. And then for the front-end protocols, it could be NVMe TCP, RDMA, or iSCSI. So this is so this is a cloud-native block storage using local SSD, which is like a composable NVMe and API-driven deployment. And then the other mode we could do is we could make use of, we can have the file as a file storage. We could use ZFS that uses a zpool mirror instead of the Linux RAID 1. So the zpool mirror is pretty efficient because it does not do a blind mirroring of the entire disk. It only copies only the written data block. It knows, so that way it's efficient with that. And then this makes it same as the FSX on AWS. So we try to fill the gap using this on other cloud providers where they don't have this FSX but ZFS workload. Protocol is NFS or SMB, just uses OpenZFS. And here also we try, the RAID 1 also has a bitmap journaling which can remember the written data blocks so that it can make use of that for efficient resyncing so that you don't have to write the entire disk. And ZFS already knows that, has a very good knowledge of where the written blocks is. So we get this 2.3 million IOPS using the older N2 instances. The newer ones can do that, but it's pretty expensive. So that's why Google was pretty generous when they launched the local NVMe. They did not have any restriction. You attach any number of SSD with very good network bandwidth. So again, putting the architecture in perspective here, this is for disaggregated storage nodes. So, yeah, it's a true separation of storage and compute here. So what I mean by that is, there are solutions wherein they try to do client-side replication. But here, here they try to do replication. But we, on the other hand, we do it on the server side. It's pretty transparent to the client. We don't burden the client with all the replication traffic. So that's one difference here, server-side architecture. So here on the back end, we could use RDMA too. We have tested that. We'll announce it pretty soon. So we would be the only only solution on public cloud to support RDMA. There's no other cloud provider has it, and so probably you guys already know who has RDMA on the public cloud.
They don't do that all of them. Only there is actually there is only one cloud provider who does RDMA. I thought it was all of them.
No, not for general purpose. For HPC they do have some RDMA.
Yeah.
For GPU nowadays they do RDMA. As a general purpose RDMA, they don't do that. Amazon is close to that. They have Amazon some EFS or something, not EFS. That's what the enhanced networking they have, which can do pretty close to RDMA.
So Google
doesn't have that, and Azure has something close to that, but it's not widely available. It's like they say it's a MANA instances that can support RDMA, but Oracle seems to be very they seem to be the fourth. They do everything pretty much like RDMA focused these days. So you imagine like you could have like a 3 to 4 microsecond latency with RDMA compared to this TCP, which is above 100, 120 microseconds. So that's advantage, right? So when you do server-side replication, so if RDMA is available, we could use that. But if it's done on the client side, then you cannot expect each client to have this expensive RDMA instances. So there are like a lot of different product differentiation here, which we think we are positioned compared to competition. This is much more elegant. So 2 modes. This is the MD RAID 1 and ZFS. So for the front-end protocols can be iSCSI or NVMe TCP or NVMe RDMA. So the way we propose the solution is we do like a SLA, the performance guarantee. So we have the customer can pick all these tiers, performance tier. So this is talking about the infrastructure cost only, not our software cost. For example, if you look at this thing at a GCP Ultra, you could do by using those old family N2 instances. They're pretty cheap.
So we get some better performance on GCP, and it costs less than on AWS. So there is no way to go to AWS. You should stay. Actually, it's better to go directly to GCP.
Yeah. So provided you use a older family of instances, if you go, they're caught up, right? At the beginning, in order to bring in customers, they just provide everything for kind of cost effective. Now, when they switch to titanium SSD, they do have a lot of restriction. You gotta have many number of cores. You need to provision a high-end instance in order to achieve 2 million IOPS. Whereas if you stick to the older N2 family, you could get it with the low-cost Intel Ice Lake family. So that's why we don't go beyond 1 that, because if you do already 1 million IOPS, it's 5K cost for AWS.
And so let's imagine if I don't use your solution, I buy from GCP or AWS, So a kind of EBS storage where I put my file system. So what would be the performance, just to compare, the performance and the price?
Yeah, price is expensive. So if you try to use the
Okay,
extreme, 19 times, you
Faster. Okay.
yeah, faster.
Okay.
And the cost, also I'm pretty sure PD Extreme is expensive.
Mhm.
Yeah, you could see, because the thing, because you are running on a local SSD, it's going to be faster. But the downside is the data is not protected.
Mhm.
If you try to use as a single instance, that is why you need to active HA with with that replication to protect it.
Mhm. Okay.
So why Maya is different?
Yeah, exactly. Nowadays, yeah, we are saying, well, yeah. So first the cloud native, we only compare it with the other cloud native similar solutions like us, like Volumes, a player right now. And then older players like, of course, we are not comparing against the cloud, the vendor provided storage. We are just comparing it with existing solutions. If somebody wants to do NVMe or Fabrics on a public cloud, they would go to Silk, or they would go to, let's say, those are well-known enterprise solutions. They could go to the new player, is Volumes. So those are the cloud native players.
You hear about Silk a lot?
It used to be there, like it used to be like a Caminari or
Yeah,
something
yeah,
like
yeah,
that.
yeah,
Yes,
yeah,
yes,
yeah.
yes,
Okay.
yes. So, but yeah, that's the difference. They have this older architecture. This controller, the storage controller could be the bottleneck because it's trying to provide data management services unnecessary. Here we try to keep it simple. You want high IOPS, bare minimum data management services. Just a replication, use a Linux data plane, server side replication, just a pair. And when you want more, the way they do is they have a big cluster storage solution. They would go and create a LAN or create a RAID group and things like that. Rather, we have to get away from that concept. If you want one more client volume, IOPS, you just deploy that one more pair using our Terraform, and within 2 minutes it's ready, and the client can access it. So that is the model, right? So this way you try to avoid the server side bottleneck on the controller. So here, these are the key points here. So we do not have any call home or anything. You don't have to be connected to the internet. We are not trying to do a managed service wherein other other solution they need to be connected to their billing, and they'll monitor what nodes are provisioned and things like that. There is nothing like that here. No need to have any internet gateway or anything to these solutions. And then we could be more future looking, because we could do RDMA. It is not a single pony trick. NVMe TCP, we are not sticking to that. If it's available, RDMA, and yeah, you might as well make use of that. We already validated on the cloud, so both the block and file, it's just like a little switch during deployment. You just say, I want the FSX mode or the block storage mode. It automatically does the provisioning in the script. Yeah, so we just compare it against with the competitor who is doing a client side RAID 1. So it's great. So the client side, let's say there's a failure on the storage in one of the nodes, then now the client is participating in the recovery now. It's putting into unnecessary stress on the client. Whereas on the server side, if a node goes down, the client is pretty much transparent to it. It doesn't know that, well, there is a little delay for the reconnection. And then after that, the client proceeds. So the entire stack is not subjected to the failure in our architecture. In the client side, there can be some, it can be chaotic. we don't know what stack it is running at the time and how they are running. So because the replication traffic, they're trying to repair the block store, but the SSD is happening right on the client, and so that's that advantage over there. So that kind of clear.
So how is your business plan? How do you do your business?
Yeah, well, business. So we first is we got everything on the. Okay. Yeah, we tried first. We tried to put everything on the cloud as a marketplace solution, so that it can be directly consumed by anybody who wants. It's just, this leads come from the cloud provider itself.
So you get subscriptions,
Yeah.
flat subscriptions?
No, yeah, it is. So with the pricing, we have a flat model wherein it's per CPU based, like a few cents per CPU. That is the model there. It's not right now. It is not based on capacity.
And when you say CPU, it's like an individual CPU, not per core.
Yeah, it's per core. Like let's say the way they have, that's how the cloud is.
It's always per
Yeah, they
core.
always.
Yeah. And
vCPU is
Yeah, exactly.
and how big is your team? I mean, have you got developers? Is it just you? Have you got a bunch of people?
Yeah, a bunch of people to develop.
Yes.
And these days, it's a lean and mean startup.
Sure.
Yeah, we have developers and that is the advantage. Like if you're on public cloud, so the entire marketing support comes from the themselves partnership. For example, the PR press release, Azure Microsoft partnership allows us to provide they do provide a PR for us. We have get option. By being a silver partner, we could do the PR right now.
So
And
how many people do you have? How many people do you have?
How big is your team?
How big my team is? It kind of is like scalable. It's just when the demand comes, we try to increase and then shrink it over the COVID time. So I would say it's roughly about 10 people in the team.
And so your typical customers would be more in the media, more user of a database. What kind of profile?
Yeah, who are your
suits the
clients?
best for?
Yeah, we just identified some use cases, right? We try to address both the file storage and the block storage here, depending on our client. So if somebody is using this MySQL, it could be the high-performance database. Like somebody wants to do a self-managed Postgres compared to Aurora on the cloud. This is pretty efficient and high performance too.
Mm-hmm. Okay.
So we have identified a lot of use cases, but this is a throughput-oriented file storage on object. This saves you 70% with the 70% cost savings.
Okay. So it's features. Anybody that needs these features will be your customers.
Yes.
There is no.
That-
Maybe the solution is also too young to determine what kind of company are interested in.
Yeah, right.
I mean, how many customers do you
Yeah, so
currently have?
Yeah, that's why to have this credibility. That's why we use open source.
Mhm.
Okay,
Yeah.
and then we use the vendor provided SDKs
Mhm.
for trust. ZFS provides the data integrity.
Mhm.
And then here we use Linux RAID 1 data as a data plane. We only have this control plane, it's ours. So that's why the risk is minimal and it's very credible. And on top of that, we could be transparent. So we provide the benchmark scripts on GitHub, wherein they could run themselves, validate. That's why we're going to call that as validate MyNS and validate MySQL. In the demo I show you. So they can run and verify themselves, they like it, they deploy it.
Mhm.
And the support and all those sales leads are, the model is provided by the cloud provider. They have sales, they provide sales leads and things like that. Yeah.
So can you share the size of your customer base, or is it secret?
Yeah, it just started, so yeah, pretty soon we will get that as
Yeah.
One, because
one.
Yeah.
Does some people, some partner ask you to OEM your
Yeah.
solution? I mean, some people say, hey, I want to embed your stuff in our more global solution.
Yes.
Is it a business model? for
Yeah,
you?
that's also part of the model there.
Okay, go to market. GCP Silver Partner, AWS Platinum Partner, Azure Galactic Partner, GCP Marketplace. Okay, Alibaba
Not there.
Beach Partner. No?
No, these are like US based mostly.
No Alibaba?
No Alibaba.
Why?
Well, yeah, like again, we try to focus on the main ones here, and then again to answer your partnership question, yeah. So these are some of the milestones, right? So yeah, well, we could do PostgreSQL PG bench. It's a well-known benchmark.
Yeah. So the
product.
product is available on all regions for all these providers. Let's say if I consider AWS in Europe,
Yes. So,
is your product available
Yes.
in the region?
yes.
Okay.
So that's that's part of the cloud provider's
Okay.
delivery mechanism. Once we publish a marketplace solution, it's made available everywhere, and so we have done these things so far. So we validated the throughput, MySQL 2 million IOPS easy, and then PostgreSQL is the one we are looking at. We could do 100K TPS. Because when you compare it with Aurora, it could be like 60K or 70K like that.
So
Yeah.
another question which is completely disconnected a bit at least. The Zettalane name come from a connection with ZFS, Zettabyte.
Yes,
okay.
exactly. Yeah,
But the Maya, where the Maya?
that's like virtualization. It just comes from virtual.
Maya.
Maya is virtual.
In which language?
Because of the Maya store,
Okay.
the initial work. That
So
I
you
did.
carry this.
Yeah,
You carry this.
I carried that.
Yeah.
That was like a SAN Maya store. But now this Maya store is used by OpenEBS.
Yeah.
Oh, so I don't know.
It was CloudByte.
Yeah.
CloudByte.
Outside.
Maya data. Yeah.
Yeah, so I tend to not use that Maya store.
So you didn't protect the name.
No, I did not protect the name. I had the domain, but yes. So so we had validated it OpenZFS, and now last but not the least, so let me see what. And I'm going to be featured in the IT Press Tour. That's going to be a big milestone for us,
Yeah.
honestly. And thank you.
Yeah, you will receive, I'm sure, some call
Yeah,
to say, okay, you were completely ignoring the past,
yeah.
and now with this meeting, your life will change.
Absolutely,
Yeah.
absolutely. Yeah.
Yeah, that's a milestone. I'm going to add it. Yeah. And
So you need the bandwidth now. You
Yeah.
need bandwidth to honor all the requests.
Yeah. And then, so back to this partnership question you asked, right?
Yeah.
So what we have right now is the solution blocks. If you look at it, we try to put the core minimal feature like blog, file. And then if somebody wants a massive scale out or something like that, we could do all this, like a cloud native Lustre. It's very complex because it's always a managed service. Right now, so what we have identified is we could do MySQL act as the metadata services, and then the object storage, nodes of Lustre with the ZFS backend. So for this we could partner with other players. And then the other trend right now is the PNFS flex files, which is like in NFS over NFS. And Hammer space is pretty popular in that space. So who knows, we could be partnering with them. So if they can use MyNS as a backend NFS server, because each node can do 4 gigabytes of throughput, and the ML space can make a PNFS parallel store out of it. And the cloud native Lustre is pretty more. There's more synergy because Lustre is already ZFS based, and it needs the metadata. It already has object storage nodes meant for bulk data, so which the MyNS can be used. So this is how, yeah, I mean, so we have all this. This is pretty standard, right? With Terraform, what we have done is we just combine all these things inside one script, wrapper script, like validate MyNS or MySQL. You just tell what region, what your account VPC zone, it will just provide that. Yeah, that's the final closing slide I have. Just open for questions, and thank you so much for coming over and meeting me. Yeah.
Thank you, Sam.
Thank you.
Yeah, thank you very much.
Appreciate it.